He just arrived today by car, and he's going to talk about the IoT architecture fundamentals. So please welcome Lucas.
Thank you. So my name is Lucas Atala. I am technology expert at Hewlett-Packard. My primary career focus is architecture of enterprise system, the data warehousing and analytic part. I am also a technology consultant in virtualization/cloud area, and I am also interested in Internet of Things, where I will present you some insight. And I made my presentation very practical, and I wanted to help the architects and engineers interested in Internet of Things, how to start with designing the system, what are the constraints, and what have to be taken in consideration when you are choosing for what way you will go. Okay, as I said, I am from HP, but this presentation is not going to express opinion of HP or any kind of HP products or this kind of stuff. What is going to be presented here is valid for all IoT products worldwide, and it is rather methodology than the product or offering. What we will talk about? We will briefly theoretically introduce what the IoT is. We will describe how the data are traveling from the real world to our business process world. We will talk about sensors, gateways, and backend systems. We will talk or speculate about if it is better to buy an pre-manufactured enterprise solution or build the own one, and we will do small conclusion and also have a Q&A session. So if you will be interested in something or something will be not explained enough, please write a note, and at the end I would like to respond to these queries. Okay, what's the IoT? IoT is a network. That's the network of global entities which are self-configurable, highly standardized, describing relationship between physical and virtual entities, integrates intelligent gateway and interfaces, and all it is integrated in a single data model, in a single network. So in business speech, that's the business and technology which is multiplied by reality. That's IoT. That's what is going on here. We are going to have a look on a reality like something what can increase the value of our existing system. IoT have DNA. It have a data, it have a network, and it have an analyze. Data stands for the sensors, actuators. Network stands for air, if we have a wireless, for a wire, if we are sending data over RS-232 or something like that. Network stands for intelligent gateway, which are translating, and analyze stands for a cloud analytical system. Transactional ERP system in company, or analytical business warehouse system, or an hybrid database. It can be close to everything. If we have a data, if we have a way how to move them, and if we have a way how to analyze them, we have a DNA, and that's IoT. Is IoT evolution or revolution? It's field of the speculation. I would say evolution, but the salesman will say revolution. Okay. At the moment, we have an IT infrastructure which consists of an ERP system, BV system, and databases, communication system, master data governance system, all our service-oriented architecture, business intelligence, reporting, stuff like this. That's already in place. We are at the moment using that. There are the companies which are producing products. They usually have a production line. Production line have an control. There is a SCADA system. There are the PLC, there are the manufacturing execution systems, and this stuff. They have a radio frequency identification in the warehouse, and that's something what is already in place. IoT is not here to replace our ERP system or our BV system. IoT is here to extend the boundaries of your existing system, but the data from the another system. So that's interoperability between the blue colors and the white colors. That's field of the discussion when we would like to extend the information on the both sides by the information which is included on the second side. That's the IoT. That's the extension of the IT system with the data from the real processes. Is it necessary to invent a wheel again? I would say why not? But first, have a look if it is really necessary. Interoperability and vertical system integrations is the topic which is quite not new. This is topic which is already 30 years old. And over these 30 years, we in various business verticals in the area of industrial automation, in the area of home automation mainly, invited many standards, which are well described, mainly open, and can be very easily integrated. The standards are already mature, tested, and used. So if we are designing an IoT system, there is not necessary to wait for a new standard or buy a standard for IoT. We can definitely use already existing standard with knowledge about them. What is the IoT? IoT are real-world entities which are enriched by sensing and actuation capabilities. Like we can see on the picture, it can be close to everything. That's something what is already in place. But once we will build a sensor into the things, and we will be able to access the things, and we will be able to read the physical state of the things, then we are starting to talk about an IoT system, because the physical entity is exposed to our digital world as a digital entity, which can be consumed there. What's the IoT data path? As we said at the beginning, on the lowest part of our design, we have sensors and actuators. Sensors are the blocks which are sensing, harvesting the informations. Actuators are the parts and servos or this kind of stuff, electric motors, which are changing the state of real-world entities. As we said, there is possibility to use IP, the Internet Protocol, for data transmission between the sensor and the gateway. That's IP for smart objects. Maybe some of you heard about 6LoWPAN. Does anybody in the room heard about 6LoWPAN? Okay, not so bad. And 6LoWPAN is the protocol which is based on the IP protocol on the UDP, and there is a IPv6 packet with the compressed header. What is amazing on the 6LoWPAN is that this protocol is not running over the Wi-Fi, but it is running over the radio. And it is running over the UDP, as we can see on the table in the picture. And we are not going to lose any single slide. That's because 6LoWPAN is transmitting the data from the sensor to the actuator via 6-tish multiplex. That's the time multiplex. We are dividing the communication channel into the table. we have a channels, several communication channels, and we are then dividing them into the time slots. So we have something like an Excel table, and we are jumping between these cells in the time and in the frequencies. And by the jumping over the time, we can guarantee that in every channel, we will have one free slot for the information. And by this way, we can guarantee delivery of information over the UDP protocol as well. For the application layer, there is a COAP, Constrained Application Protocol, which is an equivalent of HTTP, what we have today. There is a representation state transfer, communication, so we can send an update, delete command to the real-world entities, and they are processed then via the COAP. Okay. What are the sensor and actuators? That are very basic components of an IoT deployment, which are designed for sending alerts and receiving the commands. The challenge is at this low level is the security. The security of the information. If we are going to place the sensors and the actuators somewhere, we would like to have the information confidential if it is describing something sensitive. And if we have an actuator, the situation is even more critical because we don't like to have a valve opened by somebody who is not authorized. So there is very difficult to have a protected connection. There is difficult to have a certificate in the sensor or actuator. We have to be able to crypt the communication, and this sensor or actuator must be able to recognize if we are allowed to connect. So the big challenge is how to distribute these certificates, as many IoT system is operating on a huge geographical area. Next big challenge is power management, because we would like to sense the entities also on places where the electric connection is not in place. So then we have to consider a battery or a solar panel or any other way how to harvest the energy from the surrounding. And physical security. If you are going to buy a pressure meter from the Siemens, there is no problem to pay 3,000–4,000 euros per calibrated meter. So if it is stolen, then it is a problem if it is installed somewhere on public place. So sensors and actuators are not so interesting because they are with us for a longer time. They are already used in applications. All of us well know them. But the gateways is something what is not new, but what is going to be heavily transformed by the IoT. Gateways are providing us data access functionality, data aggregation and retention functionality. They are providing us exposure of physical entities into the virtual entities, which are not necessarily in one-to-one relation. They are here to integrate more field protocols into single, let's say, business protocols, which can be integrated on the another side further, higher in our automation pyramid. And on the business side, it is providing us a standardized API which can be accessed by the system. The gateways can be installed on the field, the small devices, how you can see on the picture. There can be an industrial PC, or it can be a standard server, or it can be also in cloud. The gateway doesn't mean the router as you have in home. It can be this device, but it can be also something else. So we have various types of the gateways. From the architectural point of view, the most easy gateway, if you would like to integrate it further into the ERP system or business warehouse system, is the database gateway. You will use a real-time operating system. You will run the IoT application, which will simply update the database table, which you will then integrate into the system later on. It is easy to develop and integrate. It will provide you a persistent data storage in case of whatsoever, and it will provide you a standardized access. But the constraint is that you are using a database. So the responses are not real-time, and it is very difficult to control an entity via the database gateway. It is suited mainly for read operation. Second kind of gateway is the program-based gateway. Program-based gateway is also a real-time operating system or Linux, which is running on a device where is IoT application running, which is sending the data into the presentation layer. The advantage is that we can achieve close real-time responses. We can integrate such a web services via service-oriented architecture. We can subscribe, publish, we can use MQTT or any other well-known protocol. But the consequences is that we don't have a persistent layer on the gateway. So in case of power outage, we can lose some data. And this is more complicated to use data aggregation function because you have to code them into the application. You cannot use the database function for that. The hybrid gateway combines the benefits of the previous gateways. It is ideal for large deployment because it is easier to manage huge quantities of these gateways. And it can serve also the IoT services locally in the area where it is deployed. There is not necessary to query for the information the backend system. You can consume the information locally where it is created. Consequence is higher complexity. So let's talk about backend system. If we are talking about enriching our business process by real-time, real-world information, we are asking, are we going to use existing system or will we deploy brand new system? Will we use our transactional system or will we use our analytical system? What about big data? Will we use physical hardware or will we go for a cloud service? So what about integration into the existing IT system? Every company have the ERP system because that's the system where the business process engine is running and where our business processes are implemented. And most of companies have the BV system. So that's the question, where to integrate the business process? ERP integration is complex because you need a business process engine which is aware of IoT data and is able to provide the real-world information to business process in a way that business process will be able to understand that. BV integration in the data warehouse is less complex. It is usually based on a web service or database connection. But it is providing the extension for the decision-making, predictive analysis, and the reporting part only. We are missing then the data in the transactional part of the business process. It can be integrated by the loop back to the ERP system. That ERP system can do a lookup in the BV system, but then we are losing in real-time capabilities because the transformation of the data in the BV system takes some time when it is in state when it can be used for the business purposes. So ideal solution is the hybrid system, which is combining the analytical and transaction functionality in single system. That's called big data frequently. What's cloud and big data? Big data are rather about the big things what we can do with the data than physical size on disk. Cloud is the way of consumption of IT resources in a very flexible and scalable way. Okay. Big data is about this, that at the moment between the transactional and analytical system, we have to load the data from the transactional system into the analytical system. But once we have the data in the one database, in the one data model, and processor is efficiently able to process them, we can do a real-time replication of the data. Once entered in the ERP system, that's the directly exposed in the report, which is giving us a business advantage. This is very easy to predict and load on an enterprise system because you have an amount of data, you have amount of users, and you can predict how fast an user is able to click in the system. But with Internet of Things, it is very difficult to predict how much of data will come from sensor. That's why we are looking for a cloud-like a solution, because in cloud, we are able to extend the RAM capabilities, CPU capabilities on demand during the runtime, what is not possible in physical hardware. Okay, and that's why we have this presentation. We are going to implement the IoT system. Are we going to buy the system or build the system? That's the question. All the time it is about total cost of ownership. And this ownership is a sum of effort and price. If you are going to develop something, this is not for free. It will cost the time of your employees. They are not working for free. So you have to count how many hours you will spend and what is the price of the product. On the table here, we can build own solution. Then it is in the customer responsibility. We can customize the solution. It means that we will download an open source project and you will customize it to our use case. Or we can go to our software vendor and we will ask for IoT solution. Then we will pay a bill. Our effort is growing. The price is growing. If we are going to build it, it is only our investment. If it is a simple, small solution, then it is small. If we are going to customize something, open source is usually cheaper than the corporate solution. If we are going to buy something, we will simply pay the bill, and it is usually the most expensive solution. But on the other side, if we buy the solution, the vendor is responsible for the bugs and errors, and we are not spending our internal labor cost for the solving these issues. If we are doing a unique single case solution, then the effort is low. If you would like to integrate from 5 to 10 process variable from your production line into your BV system, that's a matter of few hours, and good engineers will talk together and will integrate this data from manufacturing execution system. So you can build it very simply. But if you are looking for a platform or a highly standardized solution for something where the real-world information is fragmented, then it's better, in my opinion, to go for a platform or standardized solution and pay for it. Because it comes with various protocol translation and integration challenges, where the vendor is responsible for platform and customer only for information model. And if you will pay for solution, you will ask vendor integrate this data, and I would like to only consume this data somewhere from cloud. You will pay the high price, but all effort is on the vendor's shoulders. So you are considering only a price aspect at this kind of time. To conclusion only. So IoT is not only about protocols and sensors. It is a very complex technology solution, which including our existing IT systems as well as our real-world processes which are surrounding us. Standards for IoT are definitely missing. So if you are going to build an IoT system, you have only reference architecture, but nobody will say you use this protocol and you are able to integrate everything with this single protocol. That's why this is not reasonable, in my humble opinion, to wait for any universal standard. I would say go for IoT system now, implement it, use a gateway, integrate all protocol what you need, expose it by respect of reference architecture into the virtual entity, integrate into the system whenever when you need and use it, and gain the business advantage rather now than ever. Okay, any questions?
Business warehouse. And where in that abstract concept of IoT does the user come in the game, where he can maybe change things? And the second question is, on a transactional system, you're talking about the business engine. How far along are you on, is the development on that, and how interactive is it for the user? The user not being the developer.
User is definitely not seen as the developer. In the analytical system, that's quite easy. The question was how you will benefit. You will not realize that you are benefiting from the real world data. They are the data like any other business data. Like a user, you will use the same reports what you are using. You will have only more points what you can use for doing your reporting. And in the transactional system, in the good transactional system, in the good ERP system, that's the matter of integration in the business process engine, which is executing the business process, where the transactions are talking. So you will, again, as user, not realize that you are running an IoT ever system. The business process engine will give you the possibilities how to move on the next transaction screens based on the real world information on the encoded functionality. So again, the man who is implementing your business process into the ERP system is responsible, and he have a knowledge about your complete business process, and he is able by real world entities in the points where the business process is able to change the direction, to change it, or offer you only the ways which are compatible with the real world.
What's the limit? What's the limit in the? Let's look at it. What's the limit there in the business process engine? Just like the developer has predefined, or can he, let's say, play with the data flow or the logic flow?
If we are talking about business process is not here for a playing. That's something highly defined. At this area, in area of transactional-based system, you have strict rules. But in area of predictive analysis, maintenance reporting from the business warehouse, there you are free to choose the data. You can use on the Excels whatever you want, and you can generate the insights whatever you want. That's the place for playing. And about the level of integration into the system, as you are checking an SAP sites, there is a concept which is called a ramp up, and it is when you have developed a product and you still don't have it in production use, that's only test production used. So the IoT systems are already in test production used. So they are not sold at the moment, but they are already developed and we are testing them.
So there's time for one more last question, if you want. Are there any efforts made to get the IoT standardized?
Industrial Internet Consortium, Open Interconnect Consortiums, and many other organizations are trying to standardize. But they are only saying, writing the proposals, they are analyzing existing things, and it doesn't seem that the solution will be in a month or in 1 year. So again, if you would like to IoT, that's mainly about the data. You have to integrate the more protocols. This is no problem today to integrate more code stacks in one gateway to talk with protocols what you really need and translate between them and then communicate over standard IP network. So for IoT, waiting for protocol is not necessary. No problem. If somebody have a question, we are running out of time, if I understand. So you can find me and I can say respond to your queries when something. So thank you very much for your attention.